got a digger on site, if you ever have it, do have a look. You don't have to put it in the middle of your field, you can put it in a field edge. Obviously ditching's a useful way. Do just use that as an excuse to have a bit of a play. It can be really useful to have a look both at what your subsoil is, but also how variable it is. Because this is actually pretty uniform as subsoil goes. Many of you will have stuff that changes different depths of rock or different kinds of, so this is a drift material. So this is what would be called, the geologists call a chalky boulder clay, which is exactly what it says on the tin, which is unusual for geology. So it's a mixture of chalk and some bigger boulders and some clay laid down by glaciers, not the last glaciation in the UK because we were not under glaciers down here at that point, but laid down by glaciers. So we've got that material that's been slapped onto the landscape by sheets of ice above our heads and then exposed at the surface. So then we get G by E by M, which you've all been learning about with Ambro, I'm sure. But in my context, it's geology, environment and management, shaping and changing our soils above ground. Key here, actually, the first phases of soil formation have no management in them whatsoever because we weren't really around. So that 10,000 years ago, the glaciers start to retreat, the landscape becomes stable, it's not constantly being scraped, the wind speeds, we're moving out of the polar wind speeds, things start to settle down, the land begins to the landscape begins to settle and plants begin to invade. And for us in this hole, it's not this depth, this wouldn't have been where it would have been about here at the time, but we've got this sort of material that then starts to have plants invading and shaping and changing, so that we've got the mixing and the slight difference in colour of this material here compared with the material further down, because the environment, the literal changes by wetting, drying, and then plant roots invading it are shaping and changing this first layer of the material, which has then continued to happen for those thousands of years under the development first of grasslands and then of forests, reaching across the whole UK till about 4,000 years ago. We've got that mythical forest that stretches from the north of Scotland to the bottom of Devon, and squirrels can skip happily through it from never touching the ground. You know that story, I'm sure. So we would have had this soil formed under those conditions, with roots reaching down, mixing and biological action, feeding and mixing organic matter into the top. So photosynthesis, capturing carbon from the by the sun through the sun's energy, giving me green material and other colours too, that becomes fixed and shaped and changed and then changed by the organisms within the soil. So we've got a huge biological diversity here, fueled by the roots and the additions of organic materials from the surface, with no management particularly going on. And the soil we've got formed here is called, and again this is one of those classics of soil science naming, a brown earth. Why? Because it's brown, well, brown at the top, brown in the middle, and still quite brown at the bottom. So we have a classic here, brown earth soil, clay loam at the top, probably getting clayer until we get into this silty clay with chalk bits, and I've got a bit over the top there for you to have a look at. Quite dry at the base here. Why? Because actually it's quite tricky for water to penetrate well from the surface down into the subsoil. Water tends to move through cracks or deliberately drop out if you create a big hole. So we've got water moving through, and then anywhere there has been a crack, what we get, and those of you get your eye in might see, we get a crack. What we get is roots following those cracks time and time and time again until what we get forming about where my trowel point is, those of you with good eyesight, there's something we would call by jargon a biopole, where the soil's darkening now in the subsoil because we've had roots following roots, and we're bringing actually topsoil, we're making topsoil in the subsoil because of those biological action, and that's how that topsoil originally formed. It looked this colour, and then biological action through time has made that process happen. Now, I'm not supposed to be talking about how this soil's formed in this place over these years, but I was given a hole, so I have to, really.
Brilliant.
So we're talking then about assessing soil health. So it's important to think about how we're going to go about doing that. Not because DEFRA have told us it's a really good idea to get our SFI payment, because it's a really good idea, irrespective of whether DEFRA have told us to. So what we're doing is thinking about where and how we might do that. Where is very much an on-farm decision. You guys need to think about where the places that's really useful to keep an eye on your soil health will be. The methodology I'm going to walk through very quickly is one that works for mineral soils. Apologies to those of you with organic soils, and hence would and does fit to tick the boxes of the SFI. But thinking about where that is very much a decision for on farm. It might be about getting yield maps out. It might be your knowledge of soils to create representative places. It's useful to keep an eye rotationally on whether your soils are doing what you expect. Equally, you might use this sort of test if you've tried something different. So you've got here lays that are coming out at different times to go into cereals. I wonder if that's made a difference to my soil health. Well, then I might want to compare with and without, or all those sorts of other things. But the simplest variant of this game is I just need to get my spade out. I'm just going to stick it in the ground, and I learn quite a lot. I don't have a big hole, so I'm going to learn quite a lot about actually is there any compaction, any issue in the topsoil here? Well, actually that went in fairly easily given how clayey this is. We go in 3 sides. I'm going to try not to take out a microphone while I do it. 3 sides of a block. I'm going in 3 sides of a block and then lifting an undisturbed side, because if I go in 4 sides of a block, what I get is 4 smeary sidey mess, and I can't tell what's going on. So the ideal is to go in 3 sides. Doesn't always work, certainly won't work for those of you with very sandy soils, but the ideal is to get a block where that is an undisturbed side, so it's fractured naturally, and then the jargon says I'm going to open that up like a book, ideally not drop the bit, but hey, open up that like a book and begin to look at how the structure blocks break. Now I'm pretty sure, given we know how sticky and horrible this is, and you've probably thought that when you've been looking at it in that hole already, that you wouldn't actually mind this. It's actually been managed pretty well. It's the blocks break. Given where we are in the season, we'd expect it to be drier than this. Given the rainfall we've had, we've got some blocks, but the blocks we have break quite happily one-handed and have roots and biological activity in the middle of them. So we might use something like the visual assessment of soil structure methodology. Here's a card I prepared earlier. This is the printed from SRUC or from AHDB, so we can give that a score. At the same time I was looking at that block, and I'd make sure it was a proper full spadeful. I saw one in the top, but I would actually spend some time breaking that block and counting the earthworms in it. And I'd take some soil from around the area, roughly thinking about a 5 metre diameter area, sort of, so I can come back to it using my what 3 words location, know I'm in the same place, put it in a bag and send it away for analysis. Glamorous Assistant is now going to show us some results.
Other page.
Other page. It can just go on the floor if it's annoying. So these are live wheat sites, and one of the reasons I have chosen this Glamorous Assistant is because this here, the Glamorous Assistant can claim all the glory for. So this is a live wheat site of Mark's, sampled by Dominic and the ORC team. I've deliberately chosen 4 that are medium in texture, and we're just using the methodology from the AHDB project to now take the indicators we're using and colour them in using traffic lights, so that all of you immediately look at Mark's and go, oh, look how good he is, look how green they all are. Yeah. Or at the same time look at somebody else's and go, oh, look, a bit low in phosphorus there. And yeah, so it's pretty much for phosphorus and potassium using the indices system, but just colouring that in a way that gives us a warning, or alternatively gives us a pat on the back for the way we're managing to maintain our nutrients. But it's now starting to give us traffic lights also for physical structure. So 3 starts to put us into restriction potentially to rooting, and it's that block here where this cereal at this site was put into wet conditions in 2019, so we've got some fairly big and nasty things created by cultivation, which are giving us that score of 3. Those of you with really good eye will be able to see the organic matter line, which is just one up above the bottom there, where actually one of the reasons for choosing these 4 sites is there are differences in what level of organic matter is being maintained, with a difference there between a site that receives very little manures with its straw bale, despite the fact it's an organic site with white clover lays but used for grazing, but it's very little manure return. And then the glory site of Mark's, which is going on tape with me telling you it's a glory site. Glory site of Mark's, getting good inputs of compost and other materials, building up organic matter, organic matter in the soil in contrast. So that difference there showing us something about management. Now the key to this is fine, I get my data back, Mark could have got his data back, I could have coloured it all in green, but he'll learn most, not by just looking at those numbers, but by getting together with the other people or other people around him and going, oh, why have you got that? And what's going on there? And I wonder what's going on with that. Because it's actually in those interactions and those conversations that we learn most about how the properties we're measuring interact with management and help us think about how the decisions we make, sometimes because of nasty weather, sometimes because of constraints of rotations, actually are interacting with the soil that we have to determine whether our soil's in good health or not. The logical target is to go all green. Mark isn't all green, but that's probably because currently the benchmarking, you'll be pleased to hear, the benchmarking for this one at the bottom is probably a bit mean. So right. Actually, we think we're probably, because we're still evaluating these benchmarks when this was done, we think we're probably being a bit tough, that actually this sort of level of biological activity is probably actually pretty good, and very few UK soils would flip into to go green on that. So it probably just means we need to move the benchmark a bit, not that your soils are low in biological activity. I'm going to stop wittering because that gives you some minutes to ask me questions if you have any.
I'll ask one. How can they get that sort of analysis?
Those are just bog standard things. So it's your visual assessment and the earthworm count that you yourselves have done, and then that's just a fairly standard set of samples sent away to any of the big labs actually. The only thing that's slightly unusual in there, and all the big labs now offer it, is that CO2 burst test. So we've deliberately put into this scorecard things that are accessible to farmers and which we already know how to benchmark. So there are lots of other new tests available, but that you just get the numbers back and you go, well, what does that mean and how do I make sense of it? The project is particularly focused on finding the measurements that we can already help us to make and understand our management impacts. There are other measurements we might use too. So you might want to look at things like infiltration, aggregate stability, other biological measures. They're fine, but they're much harder to benchmark, particularly between soils and seasons. So what they're really useful for is side-by-side comparisons. For example, in a field like this, one that's in the ley versus one that's in the arable next door, what difference is that making? So we can do that literally side-by-side at the same time. If we want to compare between sites, we kind of need to be a little bit more robust in terms of the measurements we use and how we measure them.
Almost just following on from that, can you explain the microbiological activity tests that you do there? Because that's quite difficult to measure, from my understanding. But
so that's the standard. For any of you who use labs regularly, that's the standard test that both Landcrop and NRM and others are now offering. They call it slightly different things, but pretty much all call it the CO2 burst. You could use others too. It's not a particularly robust measure of microbial activity on its own, but it's a useful indicator of microbial activity. It's probably the best we've got that labs can do reliably. If we do it in the field, we can do it, but if it rains today, doesn't rain tomorrow, we'll get different answers. So it's important to have, for use in a scorecard like this, a measurement that's robust and benchmarkable. So to be clear, what happens there is, as an indicator, they've dried the soil and they re-wet it and see how much CO2 is produced in that as the microbes get back to work. So they work on the readily available sugars and other soft stuff that's in the soil. So it's a combination of the size of the pool of degradable stuff plus the size of the microbes, then just getting to work and how fast they do it. And it's a reasonable proxy indicator. On its own, I wouldn't give it the time of day. As part of a bigger set of assessments, it's a useful benchmark. And for me, that's pretty true about all of those things. Actually, on their own, they tell me a little bit of things, but actually it's taking the physical, chemical and biological stuff together into account that helps understand whether that soil is going to deliver the yields and the resilience, particularly in terms of yield, that we're looking for.
Brilliant answer. And I think that's where we'll have to leave it, to coin a phrase of Charlotte's. Thank you very much.